The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, everybody. I'd like to welcome you to SQL Saturday 1000 Portland, Oregon event. Thank you all for coming in to attend and for participating in this event. I am happy to introduce Paul Turley. He is a great presenter, and he has been a very active member of the Oregon data community and part of their leadership team. He's done a lot of written a lot of books and done a lot of presentations. He's a really seasoned Power BI guy. And today he's going to be giving us a presentation on data modeling solutions for challenging BI data modeling problems. I'd ask all attendees, if you have any questions, please put them in the questions box, and I will ask those questions to Paul when the opportune time arises. And please enjoy the session. I'm going to go ahead and hand this over to Paul.
Right. Thank you, Jessica. Probably the folks that we haven't really been thanked enough today have been our session moderators. And we just with this new format that is, of course, new to us and managing 8 parallel tracks. I think with 48 sessions altogether, we have a moderator for each session who not only introduces but fields questions. And Jessica has been wrangling that group and organizing all of our moderators. So she has done a fantastic job. So I just wanted to acknowledge you, Jessica, for doing that, and thank you. And then thank all of our moderators and our organizers who have worked very hard. This is, I think we got pretty good at running a SQL Saturday when they were on site and live, and everybody was there together, and we were pretty well practiced. And now we're starting all over again because this is a brand new format, and there've been a few kinks, but we've worked through them. So thank you, all of you who are attending today. My name is Paul Turley. I am a lead consultant with 3 Cloud Solutions. Now, if you've followed me or followed my blog, you know that I've been with Pragmatic Works full-time for about the past 2 years and several years on a contractual basis, and that has not changed. We've actually changed our name. We merged with another company, actually a couple of other companies, and we're now under the 3 Cloud Solutions name. Bigger company, same great team. We do consulting work, and under the Pragmatic Works name, they still offer training. And anyway, it's work that I love. I've been a member of the Microsoft MVP community for 11 years now, and just have a passion for being involved with the community, and particularly sharing my experience around business intelligence and analytics. You're welcome to reach out to me via the social media networks that you see on this slide. I just uploaded this deck to the SQL Saturday site, so you are welcome to download that. Before anybody asks, the demos that I'm going to be using, there are earlier versions that I've used for other presentations. This particular Power BI file, I'm not prepared to upload that quite yet, simply because all of the file paths and such will probably not work for you, but there will be future versions. Now, I will be giving a similar presentation at Past Summit. It's not going to be exactly the same thing. Actually, the folks who organized the Past Summit have been very insistent that we present fresh content, and that it's not exactly the same content that we deliver at SQL Saturday. So that will be an enhanced version of this same presentation, or a similar presentation on the same topic. All right, well, let's move ahead. So, and once again, I do encourage you to ask questions. Jessica's going to be fielding those questions, and she'll go ahead and interrupt and let me know about your questions. I do want to recognize our sponsors for this event. We were fortunate enough to be the 1,000th SQL Saturday event. We're very proud of that. And SQL Saturdays are not possible without sponsors. These are companies who support us financially, and without them, we could not have these events. And so we ask that you support these companies and opt into their mail lists. You can always opt out. It's not something that you have to do. But we just want you to recognize the support that these companies give us. Melissa Data, Red Hat, of course, Microsoft, Markham Consulting and Training here in the Portland area, and Google Cloud. And Markham is our premium sponsor, and we just wanted to call out their very specific support. All right, and you're welcome to provide feedback. You can use this QR code. If you do download the deck, then you'll have access to this SurveyMonkey survey, but you can just use the QR code, and if you want to follow that on your phone, I'll be showing this slide at the end of the presentation as well. All right, what are we talking about? We're going to be talking about data modeling solutions for challenging data modeling problems. Now, I am going to cover some kind of 100 level material quickly, but then we're going to move to some more advanced material. So if you're brand new with Power BI, I think a lot of this content will help set you in the right direction and give you some decision points and things that you can think about as you continue your journey. If you're more seasoned with Power BI and the other Microsoft BI tools, we will get into the weeds a little bit. And so we're going to go from beginner to intermediate, generally speaking, but we're also going to talk about some new features that you should look forward to as well. All right, so this is what we're going to talk about. Let's talk about model schemas, talk about different ways that you can model data. We're going to focus on dimensional modeling, and we're going to talk about why that's important and how that's important to understand the tenets of dimensional modeling. We'll talk about role-playing and role-playing dimensions, bidirectional relationships. I'll talk about how to implement, and I'll demonstrate how to implement a many-to-many relationship between tables. Talk about the use of disconnected tables, in other words, tables without relationships, importance of relationships, and how not to be constrained by relationships. And then I'll show you some very specific examples of using the switch function, and we're just going to talk briefly about calculation groups. That's a topic that I'm actually going to focus on in my past summit presentation. We'll just mention it here, but we're not going to get deep into calculation groups. And then talk about the why we have external tools, additional tools outside of Power BI Desktop, and why that's important, and when to consider using other tools in concert with Power BI Desktop. And then we'll close up by talking about composite models, both composite models that we have available to us today, and the next generation of composite models, which is a pretty big change, I think, in our journey with Power BI. All right, different schemas for different needs. What's a schema? So when we talk about tables and relationships, as we're talking about schemas, what we mean is the layout of these tables, how they're related to each other, and the patterns that we follow when relating tables together, and how that holistically fits into a model. So categorically, we can talk about flat models, one big old table, multiple tables that are arranged in a master detail type of relationship, and then a dimensional model, which holistically is kind of master detail. It's same kind of concept, but really thinking about shaping data in terms of facts and dimensions, maybe some bridges, but generally speaking, facts that are surrounded by dimensions. We'll get into that. But these are all valid schema approaches and schema patterns. It's really hard to say that you should always shape everything dimensionally. I think generally speaking, that's a good idea. But in simple models, to meet very specific needs, it might make sense just to flatten everything, or it might make sense to actually have a normalized kind of master detail type of relationship. So it really depends on your needs and your objectives. So let's start with flat tables. Now there are other products, competing products, who really promote the idea of flattening data. So using a competing product, a product that has a French name that might mean table, you know, they really kind of promoted this idea that you can connect to multiple data sources in a fairly similar fashion to the way that we do that in Power BI. And you can transform that data and bring it through pipelines, but then we flatten out all of that data into a big spreadsheet. So let's take a look at what this data may look like. Now, this is actually based on the sample data I'm going to be using today. But we flattened everything out into a very simplified spreadsheet schema or layout of data. But so if we look at the sales information, again, this is simplified, but for demonstration purposes, we can look at the sales information and just make an observation. The first three columns are dates. They have to do with orders. Well, what do we do with orders? Well, you order them on a particular date. That order is due as of a particular date, and that order is fulfilled or delivered. So based on the order date, due date, and delivery date, we can learn interesting things about orders, make observations, and analyze this data. You know, if it was ordered on a certain date and it was due on a certain date, but the delivery date was later than the due date, then that's a late order. And so we can analyze things like the the time to delivery and the whether the order was on time or not, or whether it's still open. Maybe it hasn't been delivered. Maybe it's been canceled, so it wouldn't be delivered. We also have customer information. Again, in this simplified view, you can see that we have a customer key, which suggests that this data maybe came from a system that's normalized, that was properly designed, where customers have a key or a customer number or some kind of an ID that's used to identify those customers. And customers who are of a business type of customer, have a company name. What about product information? Again, in the simplified view, we've got products have a category, they have a subcategory, and of course they have a product name. And then we have these numeric columns. And categorically, we would refer to the numeric columns that we're going to aggregate, total, summarize, and apply some kind of summarization function against as either metrics, or we might call them implicit measures, or what we call base measures. It's a number. It's a column of numbers. We can add them up, average them, get them in, get the max, get the median, etc. These are not measures specifically, but they are numeric columns that we can aggregate. We'll talk more about measures. All right. So now let's make the transition from this flat world to a dimensional model. So we often refer to a dimensional schema as a star schema. The reason for that is that it kind of resembles a star. If you think about the table containing those numeric columns that we want to aggregate as sitting in the middle of this schema and being surrounded by dimension tables, kind of resembles a star. Now, a model can have multiple facts, and those facts can share different dimensions, maybe not all of them, but if we boil this down into simple terms, it's dimensions surrounding facts. We translate this into a Power BI model, it might look something like this. Now in my model, I have online sales and I have store sales, two separate fact tables that contain base numeric columns with keys that are related to my dimension or lookup tables. All right, well, where did this, first of all, what is a dimensional model for? Why do we do that? Why don't we just flatten everything? Well, it's a general best practice. It's a pattern that's been around for a long time, and it's a pattern that's proven, and quite honestly, Power BI and other products were actually built and architected to work primarily with dimensional models. That's not to say that you have to build a dimensional model or you have to source your data from a dimensional model. It's just a general best practice. You're going to get improved performance. You will generally see more accurate results because you can clean up a lot of data quality issues. But there may be some exceptions. So back in the day, if you've used SQL Server Analysis Service is multidimensional, you pretty much had to have a dimensional model. You had to have an ETL process that loaded fact tables and dimension tables, then you built your cube off of that. Power BI gives you more latitude. It gives you more flexibility, essentially to break these rules, to cheat a little bit, if you will. But there really may be some exceptions in a well-crafted model where you don't have to break things off into separate dimensions. Particularly, you don't need a dimension table for every simple attribute. So if we have perhaps a customer location, if we have a simple set of data, maybe you don't have to go create a geography table or a separate customer table or a separate product table. However, I would err on the side of generally creating separate dimensions. So who came up with these ideas of dimensional modeling? Who originally defined the rules of dimensional model design? Well, we typically credit these folks. Now, this is a consulting business that ran for 30 years. They're well established, well recognized, no longer in business. And that's because the Kimball Group, Ralph Kimball there in the middle, pretty much wrote the Bible of dimensional modeling, really explored all of the rules. And I equate the rules of dimensional modeling to the rules of physics. They're just truths. They're just, it's just a statement of how data behaves. And if you follow these rules and follow these design patterns, things are just going to work. In physics, you've got to understand mass, inertia, gravity. And once you understand those basic things, then everything else just makes sense. And then you can build cars and guns and rocket ships that go to Mars. And, because you have to understand the laws of physics. Likewise, we can build functional databases and analytical data models when we understand the rules and patterns of dimensional design. What are they? Well, there is a method, and this is according to the Kimball Group. You select a business process, understand what it is that you want to report on. That could be a business area like online sales or store sales. And then you declare the granularity of that data. How low do we need to go? It's like doing the limbo. How low do we need to go across our date, across our products, across our customers, across anything? Maybe it's not down to the transaction. Maybe it's not down to the customer. Maybe it's not down to the minute. Maybe it's not down to the address, but it could be the zip code, could be the city, could be the state or province. So that's the level of grain. The lower you go, the more data you get, that affects performance. Identify the dimensions and then establish that grain. So aggregate the data up to, or group the data up to that level of grain. And then finally identify the facts, and then you aggregate and store the data, perhaps summarized in fact tables that meets the grain of the dimensions. Now, I'm not going to get into all of the details of the dimensional design approach. For that, you can, actually, I think I pulled this book off of my shelf earlier today. There's some great books, thick books, on dimensional modeling and dimensional modeling design. Here's a great book from the Italians. I'm not going to give you a list of books. I'm simply making the point that there is a lot of background and a lot of smart people who have worked through the details of dimensional modeling. And these are the general steps. You're going to load detailed atomic data into dimensional structures. You may roll that up to that level of grain. And then you're going to do the same thing with your fact tables, then figure out what the relationships are between these tables. Okay. And finally, it's a continuous balance. It's an iterative process. You're never going to get it right the first time. That's what Power BI is all about, is it lets you prototype. It lets us, make mistakes and learn from those mistakes, but then it lets us keep the good stuff, throw away the bad stuff, and then we iterate through the process. Okay. Let's talk about some of the tenets of dimensional design, and then we'll jump into some demonstrations. Role playing. What do we mean by role playing? Well, we're talking about role playing dimensions. So here's a very simple example of a role playing dimension. One of my favorite sets of demo data is the on-time performance metrics maintained by the Bureau of Transportation Statistics. It's essentially data gathered from the FAA about commercial airline flights. And you can go to the Bureau of Transportation Statistics, BTS, Bureau of Transportation, anyway. And you can get this data. And essentially, if we look at commercial airlines flights, what's a flight? Well, a flight is an airplane that takes off from an airport, it flies, and then it lands at an airport. And so in that leg or that flight, you have a departure airport and you have an arrival airport. They're both airports. It's just that they serve different roles. This is an airport for which airplanes fly away from. This is an airport that airplanes fly into. Now, airplanes fly into and out of all airports, but in order to be able to manage that data, because our flight table has both a departure airport code and an arrival airport code, we need two-dimension tables. So we create a table and we materialize it twice so that it can play both of these roles. Here's another example. We have sales information. We're going to look at this data. We have sales information that have multiple dates. Earlier we were talking about the order date, the due date, and the delivery date. So in this case, I have two different dates, my order date and my ship date. And I can't have one table play both of those roles. And so we materialize that data twice, in this case 3 times with my order date, due date, and delivery date. So we actually triplicate that data. That data is stored 3 times in my model. It all gets compressed, but that's what facilitates a role-playing dimension. I only maintain importing data from my date dimension table once. Now, in doing that, we really need to understand cardinality, and we need to understand filtering direction in a Power BI model. And this introduces the concept of bidirectional filters. Now, bidirectional filters are something that we try to avoid as much as possible. It's not always possible to avoid them. If you were to have a conversation with our friends in Italy, very well known at SQL BI, Marco and Alberto, they would show you how to go to great lengths to reduce or eliminate bidirectional filters because there's a performance cost. So, but let's take a look at that. So here's a more complex example of where this is actually from a data model I'd created based on the CDC's COVID case data. So over on the right side, you can see case details. Cases can be aggregated at different geographic levels. When they started tracking the COVID data, it was at the state and province level, but at the country level internationally. So we recognize the geography of some kind. It could be a county, could be a state, could be a province, or it could be a country. And my country state table kind of facilitated that geography for me. Now, we wanted to be able to compare cases to population statistics, and that data from, I believe we got that data from the United Nations. The UN data was at the country level. And so we had to bridge the country state to the country table, and then the country table was related to the population by country. Well, so now we have 2 different tables that we want to correlate. I want to say, all right, I have cases by a geography, and I want to see how that correlates with population density. Whether I choose a country over here, and then I want to see the number of cases, or I choose a geography over here, and I want to see the country population statistics, I have to do this bridging in the middle. And in order for my relationship filters to flow in both directions, we had to have bidirectional filters. Now, there are tricky ways to do this in DAX, and we'll talk about that a little bit. But just understand that bidirectional filters sometimes are necessary, but not always. In fact, there are, like I said, in DAX, there are techniques that we can use to essentially eliminate the need for bidirectional filters. There are always performance consequences when you use a bidirectional filter. And there are some design limitations. So for example, it's difficult, if not impossible in some cases, to implement row-level security through a bidirectional filter if other filters or other relationships already exist in the model. So just understand that you have to be really, really cautious with bidirectional filters. Okay, many-to-many often incorporates bidirectional filters, and here's an example. So here I have 4 separate tables, and let's just look at the outer tables. So in the upper right-hand corner, I have customers. Customers have bank transactions. Well, bank transactions take place associated with an account. Customers can have multiple accounts. So I have a bridging table between customer and account. Essentially says this customer has these 3 accounts. This account can belong to multiple customers. So I have to have this bridging in between. Transactions are always related to a single account. Now, if I want to choose an account and see the customer or customers that are associated with that account, I have to go through this account customer table. But I can't do that in this relationship, because if I choose an account, that filter is going to flow in the direction of this arrow, but it's not naturally going to flow in the direction of this arrow. Now, I can go from an account to a transaction. I can go from a customer to an account customer, but I can't get a list of accounts. So we have a problem here in this schema. Now, so the question is, show me the accounts and transactions for a customer. And that doesn't work right now. But if we add a bidirectional filter right here, now look at the direction of the arrows. This flows from customer through the bridge table. You can see that there is an arrow that supports the filter going in this direction up to account. And from account, we can get down to transaction. If I choose an account, I can go this way. Oop, that doesn't work. So to fulfill this, this requirement, this schema works. However, if the question was, I want to choose an account and see the customers, that doesn't work. Don't build a model that designed to fulfill any imaginable requirement. Build it to meet your requirements and worry about future requirements later. Otherwise, you just over-engineer your models. Okay, I just wanted to use this slide to make a point. I'm not going to read it all for you, but this is a pattern that I use. This actually came from a blog post last year that I wrote, essentially talking about how I approach data modeling. So how do I begin with a set of requirements, conversations with my clients and stakeholders, whiteboarding a high-level model solution. How do we get the data? What do we do with that data? How do we transform the data? Identifying the facts, identifying keys, identifying relationships, extracting the dimensions, then essentially eventually building out these tables, and then rationalizing that it meets our requirements, realizing that we have more requirements, and then there's a feedback loop that takes us through this part of the process again. The point of this is that this is a never-ending story. You have to be pretty old to understand that movie reference. But it's an iterative process, and you're never done the first time, and you're never going to get it right the first time. But if you have some structure to it, then you can make progress and eventually get to an optimal design. All right. I'm going to do some demos right after we talk about disconnected tables. But relationships don't always meet all of our needs. It's not always the right answer. And ideally, we can build a data model where every table is related to every other table through some kind of a set of relationships. However, sometimes it just makes sense not to create relationships and to solve business problems in code, essentially using DAX, using measures, using formulas to let a disconnected table drive a slicer, drive a filter, drive some kind of a calculation. Now, I'm going to ready up a demo here pretty quick. So I'll pause and just ask if there are questions, since I can't see them, Jessica.
Sorry, Paul. No, we don't have any questions come through.
Okay. All right. So I'm going to kind of bring this to a demonstration here pretty quick. But as you begin learning DAX, understand that there are a short list of functions that are important to understand. One of the first ones is going to be if, and that works a lot like it does in Excel. If this is true, then do this, otherwise do something else. But the switch statement is kind of if on steroids, and this is the way that the switch function works. We're essentially saying, all right, I'm going to use a table to drive a decision point. And in this case, I have a table called selected measure period. This brings us back to the topic of disconnected tables. I have this disconnected table. It's just this table floating out in space that I'm going to use to drive a slicer. And if I have grouped on, or my user has explicitly selected a period named current, then I'm going to return my store sales quantity measure value. If it's month to date, then I'm going to return the month to date. If it's year to date, etc. You can see this is just a very simple, I selected this, so I'm going to return this value. So what does that look like? So let me jump into demo land here. Let me make sure I've got the right one. And we'll pull this down to the right screen. I'm also going to close my office door, excuse me. All right, let's come back to our data model. And I promise to zoom in. So I have a table called selected measure period right here. And if we go take a look at this table, this table was actually populated just by using the enter data feature right up here. I just simply manually populated that table. If we go take a look at the selected measure period, so you can see that that just has some reference values in it. So you know, we have, and it's just a single column. It's very, very simple. So I have current, I have month to date, year to date, same period last year, previous year, and fiscal MTD, month to date. So these are just reference values, and I'm going to use that in order to drive a slicer. Let me just make things a little bit bigger here. So let's, all right, you can see I'm using this slicer. I'm sorry, I'm using this table in the column group in this matrix. So there's my selected measure period on columns. Now I have a simpler version of this. Let me find the right report page. There it is. Okay. So there's a slicer based on that table right here. Again, this table is not related to anything. Its whole purpose in life is to drive this slicer and or the column group in this matrix. Now, if I just want to see the online sales quantity value in a visual, I could just go find that measure. So there's my online sales quantity. If we look at that, it's about the simplest thing you could imagine. It is just simply the sum of my quantity column in the online sales fact table. All right. And then I have different variations of the same measure. There's the total month-to-date version of the same measure right there. I'm doing the same thing with year-to-date. I'm doing the same thing with prior year. You can see that each of these measures really are just variations or a very simple time series calculation using the online sales quantity measure. But then I've got a dynamic measure called online sales quantity selected period right here, where I'm using the switch statement. This was from my screenshot right here. So all I'm really saying is if the selected value function essentially tells the formula engine that my user has selected one and only one value, or if I am using the selected measure period period column as a grouping in the context of that cell, if there is only one period selected, if that is current, then return the online sales quantity. If that period is month to date, then return this measure. If it's year to date, return this other measure. Okay, and then that's essentially what the switch function does for us. Okay, so you can see that if I select current, because I'm grouping on the same field in this disconnected table, I'm only going to see current. Here, if I select month to date, you're only going to see month to date. But if I hold down Control and I select current, month to date, and let's say same period last year, there you can see, and here we're looking at 2007, which is our first year. So if I move that up, you can see the prior year. So you can see that that's doing exactly what I want it to do. It's giving me this dynamic time series functionality where essentially a report designer can just drag and drop these period values, and magically it shows the right measure values. So that's really what a disconnected table is all about. It's just a way to drive a list so that I can make decisions and run some calculation script against that. All right, so I will pause here and ask if there are any questions about that simple concept, and then we'll get ready to.
No, we don't have any questions right now, though Raymond made a comment that that was also known as a predefined date parameter.
Predefined date parameter, well, that makes sense. I'm sure that in different products and kind of different evolutions of these techniques that they're probably known by a few different names. But thank you for that.
Mm-hmm.
Okay, this is not a topic that I'm going to demonstrate. It's a fairly new feature, and it's actually not a feature of Power BI Desktop. I'm going to cover calculation groups in my past summit presentation. And actually work up another demo in order to demonstrate calculation groups. Though it's a feature that is supported in Power BI, it's not a feature that can be added through Power BI Desktop. So we have to understand external tools. We need to understand how to build the base calculation group as a table, and then build a dynamic measure based on top of that calculation group. But for our purposes, we're going to say that calculation groups, a fairly new feature in Power BI, we're going to call MoBeta switches. And this just means that we have more flexibility and more capability kind of compounded on top of that same concept of switched dynamic measures. And these don't have to just be time series. You can do all kinds of things with a switched measure, a dynamic measure that's based on other measures or individual calculations. So anyway, look forward to that in my my past summit session, which will be next month in just a couple of weeks. All right, now So we've talked quite a bit about relationships and how important relationships are. I think this is just a life lesson. Relationships are important, right? And I think that modeling 101 is get your relationships right. Understand how tables should be related through keys, understand how cardinality works, understand how filter direction works between relationships. After you've mastered that 100 level or 200 level skill, now you're prepared to break those rules. And so we can use a disconnected table. That's kind of a really simple example of breaking a relationship. But we can do some really interesting and sometimes some very advanced things by working outside of relationships, which kind of supports, gives us more freedom. So let me show you some examples of how this is done. I'm going to come back to my data model. And again, I'll just remind you that I have two fact tables. I have online sales here, and I have store sales here, okay? Now, when we think about the relationship between either of these two tables and geography, so let me zoom back in where I can get to geography. All right, so think about the relationship between geography and online sales. So if somebody purchases a product online, they could buy it through a store, so it could be shipped from a store. So there is an inferred relationship from geography to stores, and that's simply because stores have geography. There's a geography key in the store table, and obviously there's a geography table in the geography table. But customers also have geography. So here we see that a customer has a geography. So if I buy something online and that order is fulfilled from a store, if someone were to say, I want to see a report that shows me online sales by geography, what do they mean? Well, is it where the customer is located, or is it where the store is located? We had to make a decision when this model was designed, and you can see that decision was that customers have a geography. So that's the active relationship going in this direction that shows that if I were to filter geography, if I selected a continent or a country or a state, then that's going to give me a filtered list of customers, which would in turn give me an aggregated value from online sales, because customers would filter online sales. It would not filter stores because this relationship is not active. Now, if we were to look at store sales, same thing. So if I choose geography, store sales do not record the customer, and there is no relationship, not even inferred relationship from geography to store sales through the customer. All right, so let's see how we do this. Now, first of all, let's go in and look at this inactive relationship. Let's say that as I'm designing my model, I drag and drop the geography key from geography to store, and if I try to make that active, you can see that I'm going to get this really cool message down here that says, you can't do that. You can't do that because you have already created a relationship between these tables, because geography is related to customer and customer is related to the fact table that this table is related to. That would create a circular reference, or what's called an ambiguous relationship. So you simply can't do that. It's against the rules. All right. So what if I want to see store sales by geography? How do I facilitate that? Let's take a look. So I have a measure. I can't look at measures here in the diagram view. I have to go look at them here. And I'm going to look at store sales quantity. All right. So here's where the magic happens. DAX gives you the ability to build a relationship on the fly, to infer a relationship where a relationship doesn't exist. And that's what I've done. Oops, I'm so sorry. I don't know what I just hit that caused that to scroll, but let's try it again. I think I maybe bumped the scroll wheel or something on my mouse. And that's what the treat as function is all about. So we know that there is not a relationship between geography and store. So we have to infer a relationship in this DAX expression by saying, go get a list of an in-memory table full of the geography keys that are currently in scope. Okay, within the current context of this query, if we've chosen a geography or we've grouped on a country or selected a state, then that's going to give us the context of that selected geography. If nothing is selected, then all of the geography keys are in scope. But go get that list, build a table, which is what the values function does. It gives me a table full of geography keys, and then go apply this table and filter the geography key in the store table. Once you've filtered the store table based on this geography key, then go calculate the sum of quantity. All right, so that's what this measure does. And if I go look at a report where I've used this, store sales, you can see this happening. So already, just looking at the map, you can see that I am using that field. I'm sorry, that measure. So there's my store sales quantity that I just showed you. You can see that the size of the bubble already shows me that I'm calculating that here in this province in China that I have 1,894 quantity of sales. You know, here in I believe that's somewhere near Sydney, New South Wales. There's Sydney. You can see that I have 1,984 quantity. And so that's being applied because I'm grouping on these geographies. You know, here we can go and see Europe, and my map should zoom out eventually, and then we'll see that that's being applied. So again, relationships don't have to hold us back. All right. I was prepared for a lot of questions at this point, folks. So what they tell us to do in front of a live audience, this is a Toastmasters thing, is when you want people to ask questions, you wait for 8 seconds of uncomfortable silence.
We do not have any questions. Oh, I do have one. It says, in order to use the treat as relationship builder, does there have to be an inactive relationship link in the model?
Oh, excellent question. No, there doesn't. This inactive relationship, at least in terms of what I've shown you so far, serves no purpose whatsoever. Where an inactive relationship is useful is there are really only two DAX functions that I'm aware of. I think this is still true, that can utilize inactive relationships, and it's use relationship and oh, there's another variation of that. I'm sorry. Related table. Related and related table. To jog my memory there. And so if you have an inactive relationship, you can build a calculation. It could be either a calculated column or a measure using the related or related table functions, and it's just smart enough to go essentially do the same thing that I showed you and apply that inactive relationship. I will say that both of those functions were in the first generation of DAX, and so they're a good 6 or 7 years old. And treat as is a newer function that was introduced about 3 years ago. So that's kind of a more modern way to do the same kind of thing. I'll be honest, I rarely use inactive relationships in my models. because I'm typically going to write DAX like I just showed you.
I have two more, another question and a comment. The first question is, that is a great workaround for creating a relationship on the fly with DAX. And then the question was, will the recording be shared to watch later?
As I said earlier, because I've kind of iterated on my demo model, and just with time constraints, I haven't really prepped that up so it would be easy to share. There is an earlier version of this model that you can get on my blog. If you just go to my blog, SQLServerBI.blog, under presentations, you'll see an earlier version of this presentation where you can download that copy of the PBIX file. I will eventually go and put a fresher version up there. I just can't promise to do that anytime soon. Kind of been busy organizing a SQL Saturday, so it's just a question of time and priority. But thank you for asking. That prompts me to freshen that up. Okay, well,
one more question that came in, and that came in from Raymond. Is there a performance difference between tree as versus related?
No, I haven't thoroughly compared the two, but I doubt that there is. I have compared using treat as and a model that actually contains the relationship. My belief, first of all, my testing has not shown that there is a significant performance difference. But admittedly, I'm not testing this on hundreds of millions of rows in a fact table. So my belief is that a relationship will optimize the model to give you better performance. But using lookups and functions like treat as are probably not going to perform quite as well. However, I don't think that that's going to be a significant performance degradation. So I think the takeaway there is, generally speaking, if this table should be related to this table, design your model around that, build that relationship. However, if this is a one-off, or if because you have multiple fact tables related to common dimensional tables, and you have the kind of problem that I've demonstrated where you just simply can't build all of those relationships, you really have no choice but to do this. And in this case, the performance cost is not significant. It's an excellent question. Thinking about performance is always the right thing to be doing here. And performance tuning and model design optimization is an iterative process. I will work with clients where we will spend months and months iterating a model design and building complex reports. And requirements get introduced along the way, and so we end up kind of shoehorning new tables and features and measures into the model. And then when you step back and you look at, oh my gosh, it takes 5 different hops to go from this table to this table. We could have optimized our model if we knew about that relation, or that, I don't know why I keep wanting to say relationship, I mean requirement. If we had known about that requirement ahead of time. You're always going to learn through experience to do that, but you'll rarely have the opportunity to build the perfect model the first time through. All right, let's talk about more advanced tools. This is a reality with Power BI. Power BI is the most incredible analytics and business intelligence platform on the planet. I sincerely believe that. I sincerely believe that Microsoft have created something that is really, really special and very innovative in the industry that we've never seen before. They did so by taking a lot of existing technologies that were very, very mature, very fully banked, but also very, very technical. And the example that I'll use is analysis services. SQL Server Analysis Services is now 23 years old. It was introduced, first of all, the original code base was acquired by Microsoft and introduced as OLAP services with SQL Server 7.0 rebranded as analysis services in SQL Server 2000, re-architected and improved, and then it's continued to evolve. But that wasn't a technology and isn't a technology that is used by normal people. That's for developers. It's for BI specialists. You really have to be in the weeds and in the trenches technically to be good at analysis services. But that's the core modeling engine behind Power BI. What they were able to do was to take these complex and mature technologies and put them into a product that is approachable, easy to learn, and fairly simple. To do that, they had to err on the side of making it easy. That means that easy stuff is easy, but hard stuff becomes even more difficult. So if you want version control, continuous integration, partitioning, some more enterprise level features, that's hard to do with Power BI because Power BI is a self-service tool first and an enterprise tool second, though it has many enterprise-ready features. So enter external tools. Why do we have external tool support? Well, it's because I think that kind of the Microsoft product teams really believe at their core that Microsoft products should be extensible. Microsoft services and the platform itself should be extensible, meaning that external developers, members of the community, other folks, companies can build products and build tools on top of these services. They're not going to be supported by Microsoft. They're not owned by Microsoft. You can't call up Microsoft support and say, hey, I got a problem with Tabular Editor. People own that. But Microsoft have encouraged the use of these products, and they promote the use of external tools. Let's talk about external tools. So as of the July release of Power BI Desktop, we now have a new ribbon, external tools. Let me do the other kind of zoom in so I can interact with this. So if I choose external tools, you can see that any of these tools that I have installed, these are registered external tools. Again, not Microsoft products, but they're products that have met certain criteria. There are 3 tools that if you just install them, they will show up on the external tools ribbon. They're the 3 that you see on the right. ALN Toolkit, that's developed by Christian Wade, who's a group program manager on the analysis services and Power BI product team. DAX Studio, that's a product that is created by Darren Gosbel and supported by Marco Russo and other contributors as an open source tool. And Tabular Editor is a tool that was developed and supported by Daniel Oedeker in Denmark, a Microsoft MVP. So again, these are not Microsoft products, but they're products that everyone in these circles will use because they really are essential. These are additional external tools that I recently installed. So why do we need these tools? So if I zoom back out, let's say that I wanted to partition a table. I'm not going to go through all the steps to partition a table. Now, the only partitioning option, partition means that I physically break a table down into different storage units that I can process separately. So imagine that I have 10 years worth of sales data, which may represent, hundreds of millions of records in a table. I don't want to reprocess that every day and go back and get all of this old data that hasn't changed. I want to break it down into partitions. Now, I do have incremental refresh that's part of Power BI now, and that is a form of partitioning, but if I want to build my own partitions, I can't do that in desktop. But I can open up Tabular Editor, and here I have a different interface connected to the same model, and I can go down to my tables. I could go down to my store sales table, and here you can see partitions. And you can see that by default, I have one partition. But if I wanted to script that and then alter that script and run that script to go build another partition to say, okay, I want a partition for this year, I want a separate partition for 2 years ago, a third partition for 3 years ago, that's not a hard thing to do now. and then I could selectively just refresh any of those partitions that I want. So awesome tool that lets me take things to the next level. I mentioned calculation groups. If you want to use calculation groups, which is kind of the next level of that switch technique that I showed you, you would do that using this tool because that's not yet supported in Power BI Desktop. All of your measures can be built and managed in Tabular Editor. And you have features and capabilities here. Like I can globally search and replace in all of my measures. I can right-click on a measure and I can duplicate it. I could rename all of my measures as a group. So a lot of capabilities that aren't quite so simple in Power BI Desktop.
Paul, we got a question come in. It was, what's the document model external tool?
Here in Tabular Editor, I'm assuming that's something that somebody saw before I moved on.
Yeah, I think so. It came in at 4:58 p.m. by Donald Parrish.
So it's a scripting option. So the because Power BI utilizes the analysis services Vertipack tabular engine, the data model is described using a document object model, and there's a scripting language that can be used to both be able to describe it and to be able to modify it. That scripting language is called TOM, the Tabular Object Model Language, and then the script that you can create to alter that model, which is what these tools actually emit, is called TMSL, Tabular Model Scripting Language, TMSL. So it's related to that, and I'll admit that there are a lot of features in Tabular Editor that I've either played with lightly or have not, don't have a lot of experience with. But I've done a lot of these things in analysis services in the past.
We got 3 more questions come in. One from John Larimer. Do partitions get appended together automatically? And then I'll get to the other 2.
Yes, they do. Yeah, and we're getting a little off topic here, but it's a good question. When you partition a table, essentially what you're doing is just if SQL is a reference point for you, think of it as a bunch of union statements. So if I were to partition 5 years worth of data by breaking my table down into 5 separate partitions, one for each year, every one of those partitions would have to include exactly the same columns, same data types in the same order, and they're automatically all unioned together. That's essentially what partitions are all about, is that they just kind of stack on top of each other vertically. And if I just choose to process the most recent partition, then essentially you're going to have 4 years of old data sitting on top of 1 year of new data.
Okay, we have 3 more questions for you. A few more came in while you're talking. The next one is, can we set the partitions to not auto-refresh in the Power BI service?
Okay, so I'm going to go back to, we're way off topic here. Yes, however, partition management is an advanced technique. It's an advanced topic. Something needs to orchestrate partition management. So out of the box, if I have a model deployed to a Power BI workspace, and I set up scheduled refresh, that's going to process everything. That's the default behavior. Now, if I want to process only specific partitions, something needs to orchestrate that, and there is not tooling within the Power BI service to do that. So you'd need to write PowerShell script and then use an automation tool to run that PowerShell script. You could use something like SQL Agent or any other scheduling agent that can run script to do that. But you're now we're talking about more enterprise level management, and you have to build these things. It's not automatic. However, the incremental refresh feature that's baked into Power BI does automate all of this. And since we've kind of gone down this road, I will talk about it briefly. If I go to any one of my tables and I set up an incremental refresh policy, let's see, this sample data uses Excel as a data source, so I can't do incremental refresh over it, but at least I can show you the interface. So I could say, all right, I'm going to turn incremental refresh on. I'm going to refresh, I'm going to partition by year. And so go back 10 years, give me one partition per year, and then detect changes. So actually, you know, do a checksum on each of those partitions and go figure out if any of the data has changed. This is a very, very smart feature, and it can essentially do what I think is the answer to your question, just orchestrate the whole thing for you. But you don't go create partitions and let it do that. You go use that dialog and it creates the partitions and then it manages them for you. Let's get off the topic of partition management. That was just an example that I wanted to use in Tabular Editor and not really the topic of this presentation. Are there other questions though, Jessica?
Yeah, there's two more, and one person said that my audio is poor for a lot of the attendees, so if you could repeat the questions. And the next question was, do you know of a technique or external tool by which one can see or visualize the data within bidirectional relationship DAX executed measure for debugging purposes?
Okay, big question. So a bidirectional filter, because of the way that a relationship exists, is going to prompt the Power BI formula engine to create an execution plan and interact with tables in a certain way. If you were to look at that execution plan, it's not going to say, I used a bidirectional filter, and you know, it's going to formulate a DAX query, and then it's going to operate against the model. So yeah, I'm sure that it's possible to look deeply enough into the interactions within the model and infer that there's a bidirectional filter. Let's put the topic of bidirectional filtering on a shelf and just say, can I see the innards of a query? Can I see what the formula engine, the storage engine, you know, the low-level operations within the tabular engine? Yes, absolutely. And you do that using DAX Studio. So let's see, when's our wrap-up time? It's 15 minutes after, so we're coming up on that, isn't it? If I just did a blog post where I demonstrated this for other reasons, but I actually talk about the technique that I just wanted to mention very quickly. If you were to just look at a report, turn on the performance analyzer and run that report. So I'm going to start recording. I'm going to refresh my visuals. Performance analyzer is going to take each visual, because every single visual causes Power BI to create a separate DAX query. I can look at the performance counters for each of those queries, and I can copy that query. I just copied that DAX query to the clipboard. We don't have time to get into the weeds with this, but I can now open up DAX Studio. And so that's going to connect to this in-memory tabular model, and I can Control V and paste that query that was generated. So using this query now, I can go turn on server timings, query plan, and I can look at at a very deep level, I can look at the execution steps and what's going on within the query engine, and you know, figure out what it's doing. I can figure out if it's performant or not. I can figure out if there's an opportunity to optimize maybe my relationships or my DAX measures. So that's a very high level answer to your question that could potentially be pretty complex. But this is the tool that you would use, and this is how you get started. Excellent question.
Yeah, and he followed it, but he was saying also something to show the context in the row filtering for that previous question.
Repeat the question one more time.
And he was asking. He further stated that he was saying something to show the context in row filtering for the bidirectional relationship index.
Again, things happen because there may or may not be a bidirectional filter. So you're not going to look at a query and see I used a bidirectional filter here. You can just simply see that a table was filtered by another table because the relationship supported it. However, I think this answers the question right here. So in the generated query, you can see that filters were created, which essentially dictates the context. So you've got the filter context and the row context of the query. So filter context here, row context here. So simple answer, yes, it's all here in the generated queries.
Awesome, that's the last of our questions we have.
Awesome. Well, hey, I was asking for questions and they came in, so thank you so much. And we're coming in just right on time then, so this is awesome. All right, so a couple things just to use to kind of wrap up. So this could be just a monstrous topic, composite models. When you connect to data through Power BI Desktop, so through Power Query, you go point at a data source and you generate a query, you will be prompted, if a data source supports direct query, you'll be prompted to either use direct query or import mode. Now, I've not been a big fan of direct query. I've made it a point to avoid using direct query as much as possible, but it has its place. And I think that ever more so it has its place. I generally will start with an all import mode query, and that data gets sucked into memory, it's compressed, it runs very, very fast because it's a completely in-memory operation. I think that folks who come from a relational database background and are introduced to Power BI learn about direct query and they go, oh, cool, I can continue to use the relationships within my relational database, and it's live and I'm not importing and making copies of data, so they tend to use direct query, and then you have all kinds of performance problems and limitations. So direct query often has performance costs. However, I'm going to show you a really quick example of where I've implemented a direct query table in a composite model for what I think is a very good reason. So I'm going to jump over to, I just barely added a couple of new pages. So here I have a simple page that shows online sales quantity and extended sales price for customers by geography. So if I go over here to, I click on this bubble, so that's, well, let's go to Berlin. So here in Berlin, I have 186 customers, and that represents $12,000 in sales for the year 2009. And that's all well and good, but we maintain a customer table with ever-changing information. Let's say that I have customer information that could change throughout the day, and I don't want to keep importing my data over and over and over again on the chance that a field in my customer detail table has changed. And so I want to maintain a live connection to that table, realizing that there could be a performance cost and other trade-offs, but it's important for me to be able to get to that live information. So I'm going to right-click on this customer name, and you can see that I have a drill-through report. And all I've done is I just have the customer key in this table, and I'm using that as a filter to drill through to this second page, this customer detail page. This is based on a table that uses direct query in my model. And here you can see that I have all kinds of customer information that may have changed. You know, education could have changed, number of cars owned, number of children at home, occupation. Those are things that I care about, maybe for marketing reasons, that could have changed. And I want to make sure that I have the latest information. But I don't want to bear the cost of going back and hitting my SQL Server every time somebody interacts with a visual on my report. That's why I used the drill through. So let's take I know that we're right at time, so I'll do this very quickly. I'm just going to go back and show you that when I imported my customer detail table, and here's the secret. There's only one customer table. This is a summary of just certain fields. This is another copy of the same table where I've brought in all those fields that could have changed. But this is using direct query. The rest of my tables are all in import mode. As you can see, it's a one-to-one relationship because it is in fact the same table. There's only going to be one customer key, but that facilitates that direct query to import relationship, and this comprises what we call a composite model because it lets me do both of those things. Now, we could get deep into the weeds talking about aggregation tables and tuning and how we can, you know, do aggregate reporting over billions, trillions of rows of data that wouldn't otherwise fit into memory. But let me wrap up on this topic as we're running out of time. And just tease you with something I'm going to talk about a little bit more at Past Summit, because Microsoft have announced that there will now be support for a different kind of composite models. So we think about the future of composite models. This is a feature that will be in preview relatively soon. This gives us the ability to not only say, well, some of my tables are import and some of my tables are direct query, but some of my tables can now be references to tables that exist in other published Power BI models. So this now gives me the ability for Fred to go create a data set and Mary to create another data set. I create yet a third data set, but I don't duplicate the data. I just point to those tables and I create this supermodel over the top of those. So this is part of Release Wave 2, which will be introduced next month. It'll be in preview probably for a very long time because it's a very intricate feature, but crazy, crazy things are going to be possible. You'll be able to do wonderful things by creating these composite models. You'll also be able to shoot yourself in the foot with bigger guns than we've ever had before. So with that, I'm going to pimp my blog and just say, if you want more, I'm working on a series of blog posts called Doing Power BI the Right Way. It's underway and it's kind of months in the making, but I've been blogging for about 11 years, about 1.5 million views so far on my blog. Please come and visit this. And then with that, I have some resources and we'll wrap up at that point. You're welcome to connect with me if you have other questions. I can't offer free consulting, you know, through LinkedIn or Twitter, but I will do my best to answer your questions. You can also reach out to me with my blog. So with that, thank you very much. Thanks again to our sponsors, and you're welcome to provide feedback through this link.
Yes, thank you so much, Paul, for doing this presentation today. We really appreciate the time you took to put this presentation together and to present for our group virtually this year. I also want to go ahead and do a quick shout out to our sponsors and thank them for funding us and helping us to be able to offer this event to everybody for free and to be able to just be able to reach such a large audience. And again, encourage everybody to please fill out the feedback presentation feedback form. So thank you so much, everybody.
All right. Thanks, everyone. Hope to see you at Past Summit. And now it's my turn to go moderate Armando's session on Synapse Analytics. So maybe we'll see you there. Thanks again, Jessica.